Welcome everyone to the August Mathlib community meeting. We've had a lot of exciting developments since the last one. And I thought it'd be fun to give the most recent version of ChatGPT a challenge. And I've been helped out by Yael, who has provided something that should not be easy to do. So I'm just going to write a prompt, which I haven't thought about, and then copy in the code. Okay. Okay, so let's say, please fill in the sorries, the following lean snippet, so that there are no errors and no warnings. I don't know if I can do this, but let's find out. That sound good to everyone?
And no axioms.
Well, yeah, okay.
But don't you want to delete the comments?
I think that's fine. I mean,
even if it came from the first one, I would be very impressed, because the proof I know of uses a lot of. It's just a case bash, but the case bash uses basic UV and geometry to do without loss of generality. We can order the points in around the circle like this, and I don't think that's easy to do in Mathlib with Mathlib either. So,
is this going to take 15 minutes?
Oh yeah, it's going to take like 15 to 30 minutes.
Yeah, we should do something else in the meantime.
Yeah, well, I'm just going to start it off and kick it off, and then we're going to talk about other stuff. And when it returns, we'll come back to it when there's a lull. Right. So, it's just a fun little, party favor, party game. There we go. That's the correct analogy. Party game. All right. So I hit enter. All right, I'm hitting enter. Okay, it's reasoning. I will stop sharing my screen. And we'll turn back to the crowd view. And I mentioned a few potential topics that have interceded since the last meeting. Those are dependent, I think, on people's experience and information, level of familiarity with them. I say that almost by providence. Oliver appears in the center of my crowd view. But perhaps I should turn it over to him to give us a little introduction to what the Mathlib initiative is for people who are interested.
Sure. Yeah. Thanks, Matthew.
Thank you.
I am here because of the Mathlib initiative, but I have not prepared a statement, so this will probably be quite brief. So the first thing I should say is the Mathlib initiative is it's legally a program of Renaissance philanthropy. So Alex Gerko has donated, probably people know most of this, but he's donated $5 million to get it started. When you do that, you need to be inside some legal entity. So for us, we've been very happily supported by Renaissance Philanthropy, and we're now a program of them. We is at the moment Johan Kamelen, who's the director, Adam Topaz, and me. Pretty quickly, we are hoping that we can use the money to hire a bunch of people to help us support Mathlib and the work of the maintainers and support the community in general. I don't say too much because, well, for a start, Johan really should be making all of those calls. But the sorts of important work that we think needs doing and that we, applied for funding to do is helping with the queue. We have a massive bandwidth problem. This is a great problem to have. It's a problem we want to have. It was more, a huge number of contributors and a huge amount of incoming material to Mathlib. But we do need to solve that problem, and I think the Mathlib initiative should be quite effective at being able to do that if we can use its resources to increase the bandwidth available for review of Mathlib PRs. But we want to do more than that. We also want to, with that huge scope, to improve our documentation, our educational materials, our support for downstream repositories. Like, we have very significant downstream repositories, which, maybe FLT gets some like special assistance, but which of course it should and it deserves. But we would like if this was something that just worked well for anybody who wants it to. So we kind of foresee that in time, an ecosystem of repositories should come to exist and exist well. We also want to give one of our lower priorities, but it is a priority, and probably these weightings can change over time, is to support efforts to apply AI to formal mathematics. And then, there's just like basic engineering work, which is currently being done by mathematicians. You've got these people who are like professors of mathematics, currently like fixing CI, and this is just not a good use of humankind's resources. We should just pay, people who's are expert at that to do it and let the mathematicians do mathematics. So that's all off the top of my head, but I'm hoping that gives some color on the Mathlib initiative. Probably leaves a lot of questions unanswered, which you can ask now. I may or may not be able to answer them.
Great. Are there any questions?
What's it going to look like? You're just suddenly going to start advertising jobs in September?
Yeah, I think so. I mean, we're currently making a web page. It exists, but I'm not going to tell you the secret URL. It's unguessable. So it'll look like a website, in a week or something. And then we will have. I think we will have a bunch of jobs. Probably will take us. We haven't even got our own contracts in place now, and we almost do, but not yet. That we there is Johan, Adam, and me. So we still have a bit of setup to do, but we've made a lot of progress there. And then once that's done, we will think carefully about exactly what the roles will be, and that'll probably be a combination of, open advertisements and maybe some, direct approaches.
Other questions?
How are you going to ensure like integrity of the reviews and things like this?
Yeah, well, review. I mean, I think as has always been the case with Mathlib, we learn as we go, and that will continue to be the case. It's also not going to be the case that anybody's going to get merge privileges who's not already a maintainer, and we have been extremely, extremely careful about who we give that power to, and I think that has worked well. And I find it hard to believe that cannot continue to work well. I suppose you might argue that the same people with different incentives could behave differently, but I'm personally not especially concerned about that. And the other thing is that, as we're figuring out how to best use the resources to increase bandwidth for the queue, it doesn't necessarily mean, it's likely in part to mean paying people to do review, but it doesn't necessarily just mean that. There's tooling. We've already benefited substantially from, Michael Wolfgang and Johan's work with the queue board. And there's also just triage. We do almost no triage. I shouldn't say that we do almost none. There are some people who do some very valuable triage work. But, there's a huge scope to do that. And that's just boring work that nobody wants to do, but doesn't really have an impact on, actually a merge decision. It does have an impact on, getting stuff to the attention of the right people. But I think the short answer is it'll still be the maintainers of the keys. Mathlib is still and presumably will always be in the hands of the maintainers. And those are a very reliable and trusted set of people.
Okay, and then something which is going to change very differently how I think about this initiative is, are those jobs going to be full-time, or are they going to be part-time?
Mixture, depending on probably the individuals.
Depending on the individuals, okay.
Yeah.
That's how the lean FRO works, isn't it?
More questions?
Oliver, just to clarify, that's probably a combination of the individuals. Like if you already have a position somewhere, then maybe it would be part-time, but also for the roles you'd be hiring for, right, as well.
Yeah, totally, yeah. Yeah, if we want, a bunch of the people we'll want to hire presumably are going to be people who are professors in mathematics. If we're lucky, they'll say we'll give you a day or two a week. If we're, they're not going to say, "Great, I resign my decades-long, extremely valuable, really hard to," you get the idea. Yeah, sorry, actually, I realized I wasn't quite answering your question because your point was about the axis of not the individual, but about the work. And what I was trying to say there is that work will have to be done by people in those positions, and so those two are intertwined.
Oh, wait, so you're saying that you're going to give those people work which will not be given to anyone else?
No, I'm just saying that, no decision has been made, right? But if I look at the obvious pools of people, and there's always invisible pools that you can't see, but if I look at the obvious visible pools of places where I can find, say, review work, since it was the first thing that I mentioned, with the information available to me today, a bunch of these people are professors of mathematics, and I'll only be able to get them part-time. And so that's just, so kind of repeating myself now.
Anyone else have any questions? Who's running your webpage?
Kim Morrison has done loads of the work. Johan has also probably done a bunch of work, and then Adam and I have done little tiny tweaks and feeling a bit guilty about not doing more.
I mean, are you using, these are questions.
It took the lead, Kim's idea, which was good. I mean, probably in time things will change. You use Verso, so you copy the lean FRO's webpage. That implies using Verso, and then you change it all.
I see. Okay. Other questions?
I'm sorry, I'm eating my lunch at the moment. I timed my day terribly today.
All right. Well, I appreciate you showing up and giving us such useful information, Oliver. It's really great to.
Come on. I'm delighted to be here.
Yeah.
I'm also excited about what's going to happen. I think this will. I think it'll have a really positive impact. No, Eric. Yeah, webpage is not live. Yes, it is live. There's a secret, but it's in a terrible state. So it's got a secret link that's unguessable.
Any other questions? So in a similar but very different vein, maybe I should also mention the recent establishment of a new NSF Institute, the Institute for Computer-Aided Reasoning and Mathematics. The goal of this institute is to take all the tools that we're really seeing rapid development in around computer reasoning, things like formalization or SAT solving, and especially machine learning and AI, and try and foster the adoption of these tools within the mathematics, natural language research community. I mean, formalization in and of itself is its own research project, but the other ones, I think, have a lot of untapped potential to help get insight or maybe even answer questions that have been pressing on the mathematics research community for a while. And so this is a new institute. It's on a pilot program for 3 years. It'll be physically located at Carnegie Mellon in Pittsburgh. We have space. Hopefully it'll be renovated and ready to go soon. It will employ, and this is a big difference from the existing NSF institutes. Maybe you've been to AIM or IPAM or IAS or SL Math or ICERM or MC. The main venue they use, the main method they use to foster research is bring a bunch of people together in the same space for varying amounts of time, let them talk to each other, maybe support them with other logistics, and then hope that they can create really interesting and useful pieces of work. And that's been very successful. There's a reason why, grants in mathematics often have a large component that's just travel. You get to go together to one place, sit down, hammer out ideas in a way that's not effective over a long distance communication via email or Zoom or something else. So ICARM will maintain a small technical staff. Right now we're budgeted for 3 that's supposed to address all of this scope in terms of computer-aided reasoning. And so the goal is not to have people who will necessarily spend and be embedded in a particular project, but ones who can jump in, fix a problem, and jump out, or be an intermediary between groups that have problems, people that have expertise outside mathematics, so that we can put them together and then maybe help them use any kind of extra resources that they need, something like GPU access, what have you, to get those questions answered in an efficient way. And so we don't have a website. I was on a meeting yesterday. I was chided for not having a website yet because of all the interest that's being generated by the announcements. But we want to make sure that we don't put anything too crazy up and that we take advantage of the opportunity. So if you want more information, Jeremy Avogad, as everyone here probably knows very well, will be the founding director of the Institute. I'll be the associate director for scientific activities. We have a host of other really impressive individuals that are going to be involved in the administration, because there's a lot of things that we need to do. And they're mentioned in the announcement on Zulip. So, if you have questions you don't want to ask here, or you have ideas, right, feel free to reach out to one of us and we can chat some more about it. I'm going to try and because of the way the funding situation is right now, we kind of had to hit the ground running as fast as possible. Normally there'd be a bit of a build up. We could prepare, but we're out the gate and we're going. So any help from the community, that's what's going to make us really succeed. So we appreciate it.
So it's not really lean specific.
No, it's
much
not
broader.
Yes, certainly. I mean, you can look at the 2 people I mentioned in the administrative roles and see that that's going to be an important component. But I think if you're really going to hit all of research math as much as reasonably possible, for instance, I was at the Summer Research Institute for Algebraic Geometry. This is a once in a decade thing that happens. Like in the West, it appears, over the past 40 years or so, I think. And it sort of recaps the past decade, important results, people speak, kind of like an ICM, but just for algebraic geometry, only 10 years, because you can't get funding for every 4 years. And so one of the sessions was on combinatorial algebraic geometry. And if you've seen where machine learning has really been prominently deployed to solve problems, it's in discrete mathematics, right? Because the data types are very low level, very close to the machine. And so, you can not have to put in a lot of work to encode them in a way that's faithful and then train a model on them. And so the next step up would be, well, if you want to do algebraic geometry, why don't you do things that look like algebraic geometry, but on these types of structures? Talking about matroids or what's this, sand piling or other things like this. And so I talked to people there, and almost uniformly they could come up with, oh yeah, I think this would be a good question, or I think that would be a good question. But what they lacked was any kind of time or energy, bandwidth, expertise to spend, months learning a completely new skill from scratch and then using it for their particular research. So it'd be much easier if they were paired up with someone else who came from that milieu and had an interest in pure mathematics. We put them together, give them some resources, and see what they can do. So that's the plan for that.
So an obvious question for me is, how is this going to interact with the Hoskinson Center?
So the
Because they are
Hoskins
going to
Center
be
is,
located in the same place, right?
well, I mean, they're different buildings.
Different buildings, sure.
We have different buildings. And they really serve different functions. So the Hoskinson Center is about research. In particular, it's about research at Jeremy's group.
Hmm.
This ICARM is about fostering research across all of mathematics, especially in the US. Right. So it's, I mean, at the level of like, maybe stepping back, it's kind of like running a lab versus organizing a conference. One of those, you put your name at the top of the paper every time, and the other one you don't. But at the same, the same product should come out of both, right? It should come out good research both ways.
And Jeremy is going to direct both of these.
Yes, Jeremy's going to be, he's on vacation this week, and we're trying to spare him and give him
I
one
was going to
last
say-
pristine vacation.
I
But
was
yes,
going to
he's
say
gonna
you are
use-
going to end up with 3 very burnt out people with your engineers, but actually let me correct that too. You're going to get 4 very burnt out people.
Well,
Yeah.
yes, we'll, I personally, I'll do the best I can to take the burden off. But yeah, no one is going into it with their eyes closed. We know this is going to be a huge lift, and so we're going to try and learn from all the great institutes that have come before us, what they've done well, what they wish they would have done. Try and employ that. We're going to lean as much as we can on the community, in the Lean Prover community, in math and AI, and other venues, right? And try and take all the interest that's nascent, that's bubbling, and sort of throw a Mentos in there and see how it explodes.
It's not immediately clear to me you're going to end up with 3 very burnt out people, because a lot of the math people might just say, well, I'm not remotely interested in using computers. I mean, there'll be plenty of people that won't take the bait. It'll just slowly dawn on people that maybe they can use computers in new ways, but it might not dawn very quickly on a lot of people.
There are definitely 2 schools of thought on the demand we will experience. So talking to some people, you will be overwhelmed. With 3 people, I think we'll be overwhelmed pretty quickly, which is why those people aren't necessarily, I mean, we're going to have to budget the time. We're going to have to take proposals. We're going to have to be able to allot their effort in a sensible way. But, we want to try and structure it in such a way that it's not just focused on a single project, a single research group, or any single collection or group of individuals working on a set thing, because those people will need a lot of assistance, right? If you think about all the projects that you heard about at the last conference you went to, and you think about all the problems they have that need to be fixed, say in Mathlib, you take 3 people and set them on that, it's still going to take them a long time to get that job done. So, building capacity using those 3 people has got to be the main goal.
Wait, sorry. So actually, this institute is not working the same way as other institutes, in the sense that you're not bringing people to meet other people. Like you're not bringing two groups of people to meet each other. You're just going to bring mathematicians to meet those same 3 people every single time.
No. So I've emphasized the different parts, but they're still the same components as other institutes. It's just there's a bit more of a different balance. The other institutes, they employ people full time, and their job is to help mathematicians, but it's to help them find housing, right?
Yeah.
Or deal with their travel, right? Or deal with childcare or schooling or things like that, right? If you have to spend a long amount of time in say the Bay Area at SL Math, you'll interact with a whole bunch of people who will help you with these kinds of things. And so now just imagine instead that these people are turned into, meta programming experts, right? Or machine learning experts or something like this, who can help you troubleshoot particular problems, but it's still the group of mathematicians and people outside math that are driving the research mainly.
Okay.
So we definitely have funds And we definitely will have events, in-person events, in Pittsburgh and at other venues.
But
So if you
how are
have
you going to
ideas,
Yeah, sorry. Where are you going to find those people who can work with computers? Apart
the
from
people who, the
you have
in-house,
so you have 3 resident ones, and then you're going to have a like are you going to find because like the mathematicians, you're going to find them in mathematics departments, but where are
yes.
you going to find the people to meet with them?
Are you talking about the in-house staff, or are you talking about
Yeah, no,
the,
not the in-house staff. Yeah, like
okay. We're gonna have to, I'm running under the supposition that there's a large population of people who work in very nice jobs in tech that also love mathematics, right? They have a love for mathematics, but they, much like Oliver mentioned, they don't want to leave their job. It pays much better than a mathematics professor, much better than a mathematics professor, and they get to do some cool stuff there too, right?
Mhm.
But usually these jobs allow a little bit of flexibility, right? You usually get some 10% time or something like this, and hopefully we can also work with industrial partners to help pair people up in situations like this. Or there's people who have already done and made all the money they feel like they need, and they're looking for something interesting to do, right, with the skills that they have, and they really like math, but they don't necessarily know that they could contribute at the ultimate level of research until now with these skills. So I think there's a group of people out there like that. There's also a growing group within the mathematical community that's developing these skills directly. And so,
Okay, so the people you're aiming for are not in academia, but rather people like Julian Berman or Yakov Pezhersky, who are very interested in mathematics but need to do it on their free time because they have a day job.
yeah, that's one group.
Okay.
I'm hoping that we'll find a healthy portion of people outside of mathematics that have the time and the interest and really are intrigued by collaborating with Fields medalists.
Yeah, I must say
On
it's not at
problems
all what
that
I was expecting, but it looks very interesting.
It's probably people that aren't already in the Zulip.
Yes, yeah. I mean, we're gonna have to work hard to try and throw out the nets and catch these people and get them aware of what is going on. So that's going to be a challenge.
But I think the XTX example is a good example of there are people that are in companies that are interested in participating. And like, sure, me and Julian, like we're in the chat, but there's the dark matter of people who are interested in, who can't just take time down and like participate in the chat and chip away. Some people want to put money into it, like Hoskinson, and there's like a lot of people that are in the in-between on that spectrum that probably could be engaged with.
And we'll look at every potential avenue to reach these people and make sure that they have the incentives and the opportunity to dive in if that's really something they're passionate about. Right. I mean, I could sit here. We have ideas for initial workshops for these kinds of things, right? And I could talk about them, but maybe a recorded YouTube clip is not the best place to talk about potential workshops just yet. But you don't have to think too hard to imagine how you would start off trying to get awareness, bring mathematicians and these people together, focus on some problems, talk about different aspects of how things have worked before, how they could work in the future. One model that I was part of was this Frontier Math Tier 4 symposium, where, to my eyes, they brought a bunch of people together, and that really catalyzed the development of problems. The number of problems shot up very fast once people got together, talked about things, and got engaged, versus trying to reach out to people via social media or email or other venues. Mm-hmm. All right, but maybe I should talked enough about this. If there are other questions, I'm happy to answer them. And we could circle back to those questions, but I want to leave some time too to talk about some of the other issues, or not issues really, but other interesting developments, exciting developments that we've had. One thing that I'm personally very interested in is hearing about people's experience with Grind. If people have experiences they want to share, that would be great. If people can explain what the scope is exactly, that would also be great. I understand that people aren't here that amount of experience, but let's just open it up, the floor, so people can share their experience.
Well, I confess to not having read the details of the reference manual yet. To be honest, I was hoping to have someone say something meaningful on the topic, but I will say I've just been very satisfied with Grind solving a bunch of goals that I no longer had to do by hand, or even with a few simple tactics. It's been satisfying to see this.
So can you, when you say things you did by hand, can you share a bit more about the context you were in and what it did?
Not easily.
Okay, no worries.
I mean,
no worries.
it was a lot of just one of these things that you're like, oh, this should be obvious, but Aesop can't do it and Simp can't do it. Like, it's one of these things that you just like automation to solve, and you feel like all the pieces are there, but none of the existing automation already did it. So.
Oh, Oliver shared a wonderful example from a pull request.
Yeah, it's not my pull request.
In the
Somebody
chat.
else did this. But yeah, it was quite like what sort of thing Gyro was just talking about, where is in this. I've been doing this like root system theory recently, and these are kind of objects that are on the border of linear algebra and combinatorics. And
so this was your question.
Yeah. A few months ago, I was like, I can't believe I'm wasting time having to prove this obvious thing, but I have to. And it's a really annoying lemma, and I got people to give this like really short proof, which I PR'd. But then a couple of months later, Grind came out, and it's one line, it's just one tactic, no lemma. The lemma's gone, just Grind.
That's great.
And it's like the sort of thing Gyro was talking about. You keep at, you have the tactic set, this thing is true. You add another condition, you add another condition. And I don't even really think about, now that I have Grind, I don't even really think about the mathematics as much. I'm just like, is that enough? And I type Grind. No, I add another, bit of information that is ambient. And then eventually Grind says it's true, and I just move on. Anyway, this is the most striking example that I've seen, because it happened to intersect with a pain point in the past, which is now just gone.
Yeah. So I must also say, like, Grind as opposed to Simp, I don't seem to be able to use it in quite the exact same way. I mean, of course, they have different scopes and everything. What I rather mean is, with Simp, I have a Simp, and then some stuff happens beforehand. I kind of just shove whatever happens beforehand into the Simp until I've basically put the whole proof in a single Simp. And with Grind, it seems that some lemmas, maybe it's just me, but I haven't yet managed to when some lemmas are used in the proof before, I cannot seem to just pass those lemmas to Grind for it to use them. I should start collecting examples, but it's more like I think it has to do with the patterns that the lemmas are being registered with Grind. Maybe I need to modify them by hand, but I don't yet have the knowledge of how to do this. And even though Kim has told us to do exactly that, right? You put Grind at the end and just stick more and more things in it from the proof before. I cannot seem to do that very efficiently.
Yeah, like with Aesop, you can say Aesop, and then you can say add Simp, and give a list of some nonsense. Grind equivalent of that would be nice. It may exist.
Apart from that, I also had quite a few examples where Grind worked, where I was really not interested in writing a proof myself. That's a very good example.
I assume that someone's collecting examples as these go through, right? Instead of having to circle back and, a posteriori scoop up all the different things where Grind has been used to simplify or golf parts of Mathlib.
I mean, there's certainly been a a number of grind golfing PRs. Hopefully we could just search for those in the pull requests, right?
There's been some user who's been just going through all the folders and applying it. It's not clear to me exactly what methodology they use to find these, because is it the like try at every step? Because
It looks to me like they're using try at each step, but I'm biased.
But like, it'd be great if we had these sorts of tools available for others, and not in the like, you can golf it now and you can't golf it at all. It'd be great to have a subjunctive tool. It'd be like, I could golf it if there was this particular step. I think there's things in Kim's head that they know that like, this is an obvious lemma that should be now part of grind, and they're working bottom up to build them in. But on a new piece of API, like came up recently with Kenny and Aaron in the valuation space, you would love to like solve these arbitrary equations on linear groups, but we don't know the right lemmas to tag with grind. And so I think there's just a missing piece between like really basic lemma that FRO or other base API people know should be for grind. How do people in other corners of API land figure out the right grind patterns? I think it's and what I mean by grind pattern, I don't mean by like the literal thing, but the patterns of usage of this new tactic.
Well, yeah, like I said, I haven't read the reference manual yet, but that's the first place to start. And at some point, I'm sure somebody should write a blog post to this effect once someone with the appropriate knowledge figures out how to do so.
I did read the reference manual, but I'm in the same state as I was, I think, before I read it. And my default these days is to, fire up, say, Claude Code or something and say, hey, look for all the uses of grind. Now, tell me where would be a next point in the library, right? Or can you explain the pattern of annotations or something like that?
David, have you tried grind on the comp files? Or there's the grind, a really great grind example that Oliver showed for more like just case bashing that one often sees in competitive problems. Have you had experience?
Yeah, I mean, I have run it on all comp files. I checked in a bunch of improvements it found. It finds a bunch of stuff. I haven't looked through all of it. A bunch of it, like, it's not clear whether it's better. Like, I care about compilation time or type checking time, and a bunch of it like makes the proof somewhat slower, and so I didn't commit those changes. So I mean, this suggests improvements I should make to try at each step where we measure those performance characteristics. But if you want, I could dig up one or two. I think there are some pretty interesting clear wins. I already have some diffs I could dig up.
FRO would probably want to know where it gets slower.
Oh, where it gets slower. Okay. I was saying I have diffs of where it like clearly wins, but yeah, okay.
Has Cloud Code been able to infer and tell you a good pattern of where it's why grind?
I mean, I say this as like I hope someone else has done this, but I have not done this. I have like this would be the next thing I would do if I had time to sit down and do something, or I would try and just sort of ship off this assistant to do something and then come back and see what it gave me if it's any kind of use. So I haven't done it yet. I'm not actually promising to do it either, because
a crazy idea. I've not tried this. Take the Trinity solution that had those like 2,000 lemmas to prove the combinatorics result that Bhavik presented on, and what if you grind pattern those and we're trying to work top down from the topmost result? How much of it can you just grind away? So part of that Trinity formalization was like, you know, they did the like blueprint and then they flashed it out a little bit more and then it auto formalized. But it's still like this huge file to read. It'd be interesting to me, is there a combination of, okay, you had some sort of auto formalization, but now you can further formalize or like pare down what the dilemmas that it figured out it needed to prove. Part of the auto formalization was in figure out what you needed to state, but maybe after you've stated it, the proofs can be further compressed in a way that like the obvious ones are via grind. So that could be a particular model system in which to explore grind API. I don't think I'm not sure the Trinity people are interested in just employing someone else's new tactic, but I think for people who are trying to use the library as a whole, understanding how do you take things that are trivial and make them easily accessible or easily, you know, swept under the rug, that could be something to try.
That's a real cool idea. Yeah, I would imagine at least Bhavik would be receptive to a discussion about this, if no one else.
One of the things I have a hope for grind is I think there are lots of lemmas that we would love to tag as simp, except for their side conditions. So side conditions like something is not equal to 0 or something is not in my set. Like think of all of the like, you know, erasing something from a fin set. Well, if it's not in the set, you still have the same fin set. And that's a difficult thing to tag as a simp lemma because your side condition isn't something that simp can obviously guess. You have to make sure you pass in all of your context right away. But it's those sorts of like, I just want to like really simplify with all of the context that I have. I think that's some of the like base API that's been grind tagged recently. I just don't have a good intuition about where it's appropriate to do that or not. And I think the reference manual was also like, well, you can't just tag everything.
I do think Kim has started on category theory, and that may be a venue that people kind of feel comfortable with to begin with, as sort of either in a holistic sense or in a very targeted and precise sense, and seeing how that grows from PR to PR and commit to commit might provide like a conceptual roadmap to understand, oh, this is the kind of thing I should be able to discharge if I do this particular annotation with this other one here and here.
A distant dream of mine is for the category theory library, and this is a hot take, for the category theory library to not do everything using type classes. I think in the category theory library, we often claim or assert certain properties, and they're all meant to be juggled via type classes. And I think Reed Barton of a long time ago, and I think Mario also said, like, you're not really supposed to use the type class system as this arbitrary proposition solver. And maybe we can get into a world where some of those claims about a particular object can be solved using tactic autoparams like grind, because right now we just use the type class system to just solve various difficult propositional statements about an object. But that's where you get diamonds if you have data in there. That's where you get loops, even though like propositional type classes, it's supposed to be able to solve loops. And you get these huge, you know, think about all of the things that you have to state in a type class style just to talk about a, you know, some sort of manifold. Or so maybe more tactic support for like description of an object that's not just a type class. Maybe that's something that grind can help. Or some sort of tactic that just is able to walk the graph of implication, is able to solve in a different way.
So Reed was, this is not strictly related to grind, but Reed was skeptical of our, which uses of type classes by us are just, I mean, it was probably not a totally precise statement, you know, but I'm just interested in that.
I don't have the exact thread,
Yeah.
but I think it was like I internalized the approach that you shouldn't stuff every single result that you've proved into the type class system and then ask, I don't like in a non-local file to access those proven facts via the type class system. So, like for example, and I have not worked a lot with the category theory library, but like has binary products. That's a type class fact.
Mm-hmm.
And depending on what category you're in, you might infer that you have has binary products through some complex other parental network of implication. Is that the right way to do it? We know that with type classes, you could like it expands out. So the example recently, you know, you infer something about the reals, knowing about something in the complexes, and that can send you down the wrong path. Or you can imagine, I'm going to use the algebra hierarchy. Imagine that I inferred something if I knew about it from the multiplicative version of it. Well, the type class system has no way to know to stop that search. If I had the wrong instance where I said like, you can infer that you're non-empty if multiplicative x is non-empty. So then it says, okay, I don't know if I'm a non-empty. I'm going to check, is multiplicative x not empty? I don't know. Let's check multiplicative x, and so on and so on and so on. And so the way that the type class system works is like through this sort of like inference backwards. And you really have to be careful to set up your instances so that they get the simpler terms on the right-hand side, not the more complex term. That was the challenge with the complexes and the reals. That's how the type class system works. And so for the category, you don't know what is on the more simpler or the more complex left-hand side or right-hand side. You can imagine a tactic that is able to recognize, hey, you know, multiplicative x. There's no way that if you do it n times, you're going to hit some result. And so the way the type class system works right now is it just terminates after going to some depth and moves on. And that's why we have slower compilation times.
Yeah, I guess, I mean, thank you. That's interesting. I guess I saw type class inference improve a lot from lean 3 to lean 4. But I still see type class inference doing things that like are ridiculously stupid that a human would never do. And I sort of but I don't see an obvious way to, you know, extract the value that we're getting from the type class system by other means. And I'm just, when you mentioned that Reed had thought a bit about this, I wondered if he had some really kind of interesting example to chew on. But yeah, anyway, it's interesting.
Well, I mean, I do think part of the failure of type class inference is our own fault, because I mean, admittedly, maybe there's a way to design the system differently, but you know, we end up putting in some instances, and some of them are just real dumb because they're going to fire all the time, and you know, it's just you're asking the system to like check something always when really you only want to check it sometimes. So I think scoping a lot of instances could be pretty helpful if we were to do this library wide. And it's just like, okay, well, if you're working in algebraic geometry, then you open the algebraic geometry namespace. Or if you're working in C-star algebras, then you open the C-star algebra namespace. And then all the instances you need are available in that namespace. I think that scoping instances could save us a lot of trouble there.
There's just a discoverability problem.
Sure. There is that. And admittedly, if the system could do this automatically, that would be better. I agree.
Right. So, I mean, if you end up wanting to, you know, yank a fact out of a different corner of the library, you have to be aware that there's this scope to open. It just, we do solve some of them with tactics. Think about the non-triviality tactic. or the algebraize tactic. Now, those are actually really nice tactics that can pierce in and kind of supplement the type class system and say, I'm going to, like, they're kind of scoped, but I'm going to go and search on under like an allow list of things that are expensive to search in the meantime, to go and introduce new facts into your context or get rid of certain goals. So we already kind of do this. It's just we don't do this on the argument level. And I think part of the also challenge with the argument level is that when you have an autoparam, that's still an argument. So call sites of your lemma, when you're going to use it in rewrite or you're going to use it in a refine, like if you're going to refine, it doesn't understand autoparams. It sees it as a separate explicit argument that you have to supply. Unlike, like, instance arguments are nice because they're implicit in a way that, like, and I don't think implicit plus autoparam works well. So that's where I think there's a little bit of a
yeah, for sure. For sure, autoparams, I have some experience with this, and it can be quite a pain because, you know, for example, you can't use there's no good way to use autoparams in simp, because basically what happens is simp can't step into tactic M, and so you have this issue that you need the you need the autoparams to be called before simp fires. And so you can't have it unify with multiple terms in the expression.
But you don't know what that term is until you try to use the lemma at the call site.
Yes, exactly.
And so that's what the type class system allows, is because there's basically escape hatch for a lot of stuff to say, I'm going to go ask a separate system to solve these in some sort of inferential way.
You know, when we touch on type class inference, we could probably talk quite a while about, like, I was reviewing a PR about condition on ideals in a ring. I had many questions, especially about is prime being a type class, and then all the statements were like explicit argument HP is prime, explicit, and then also implicit argument HP is prime.
Or filter any bot, right? Like a filter any bot is a class. Where you say, like, you know, you're Bourbankian and you want to say filter should never have been bought to begin with. In my dream world, things like my, again, hot take is that one shouldn't have type classes on terms. You should have type classes on types.
I think any bot is probably okay, though. I mean, because it applies in a lot of situations. I mean, notably neighborhoods, right?
Sure. But there you have like a structural, it's really a structural class. In Lean 3, with Rob Lewis, we proved a very interesting, to me, like a very interesting programmatic fact, which was the parser that we had in Lean 3. When you parse the number, you got the number that you actually had written. And this was a complex proof about parsers and how they step forward. Like they consume one character at a time. And as you consume it, you build up a list of digits and you multiply it out by 10 and you get the right number. And we had a proof that if you print a number and then try to parse it, you get the number. So like a proof that it round trip. To do this, there was a whole API about how parsers work. And we stated things about, oh, a parser, when it consumes a character, moves forward. Because you can imagine a parser that eats a character and doesn't move forward, or eats a character and moves 2 forward. And so you have to state a lot of things about, like are your parsers bounded? Did they progress? Did they fail in the way that, like, lawfully? And you could state this, oh, if I have a lawful parser here and I have a lawful parser here, the OR of them, or the composition of them, is also lawful. And Rob's suggestion was stuff that all into the type class system. And so that was a type class all on terms and basically parser combinators, where the end result, which was the digit parser or the natural number parser, had all these really amazing properties about it because it was really it was monadic composition of parsers. Eric Wieser, I think in the switch between Lean 3 and Lean 4, generated a, what's up, Martin?
Sorry, I didn't want to interrupt. I wanted to go after you.
Oh, okay, all right. Generated a really gorgeous graph of type class implications, and there was this weird corner of parser land, which was all these things pointing to each other. And they're like, what is this? What is going on? So I think it can definitely work on terms. I just think they have to be structural. And again, it's difficult if you say like, okay, if F composed with G is continuous, you can infer that G is continuous. Should that be in the type class system? Well, again, probably not because of that, of the like, oh, is F comp G continuous? Do I have to go find some other F problem? With filters, we don't really compose filters so much, or at least we don't have a lot of instances that say about the composition. But I think term-based type classes plus instances that talk about the composition of term-based type classes is the trap.
So how should we be doing any bot? Is the idea you use grind to do any? What is
my
grind and auto-param?
My proposal is that for places where you're going to be doing term-based type classes, you have custom local auto-params that solve it. So like basically any bot or any fact-like type class, any zero, maximal ideal, prime ideal, any bot, you have like specific to that particular fact tactic that just knows how to solve it. And then you get then you don't ever have to worry about, oh, do we have a pattern here that should it be a type class argument or should it be an explicit argument? Because you just have a tactic that is specific for that type of fact. And for prime, for example, you don't have to worry, okay, I'm going to have to invent some crazy decidable type class that is able to on the fly solve that a number is prime. I think it helps. I think it helps like bridge termland and tactic style and lemmas with the like some of these facts I want to parameterize over my space.
I have a question. So then what should happen with the type classes which talk about other data carrying type classes? Because those are terms. Stuff like Noetherian rings. Noetherian is a type class, and the ring structure is a term. So
it's I look, I don't have it fleshed out. I'm describing an idea. It's not easy. Okay, you have to invent data. You have to invent an inversion function when you're quotienting by a maximal ideal. You went from a ring, you have a proposition, and now you suddenly have more data, right? You don't want to just talk about com ring and I have is field because I quotient it by something that is maximal. So something breaks down here. And but with the Noetherian ring, that's a proposition. You're like, we're not inventing, for example, like some sort of a division algorithm when suddenly you got a Euclidean domain propositionally. This isn't a perfect solution. Like what I'm describing, I know that there's challenges here, but I'm describing a feeling. Anyway, I want to make sure that Martin has that I stop talking.
Can we circle a little bit back to the testimonials about grind? Because I don't know how about others, but I would really love to learn like what grind was successful at, because I haven't used it yet. I'm on some kind of older lean version. I didn't have it available till today. And as far as I understand, the real purpose of grind is not to golf existing Mathlib proofs. But the real motivation to use grind is rather to find proofs we haven't written yet. So I would be more interested in like hearing success stories of using grind in some downstream of Mathlib projects which don't yet have the scaffolding of all the steps until the final result. Are there people who could share some success stories?
We can hear you, Matthew. You're muted.
Oh, sorry. My cuckoo clock went off and I muted. I forgot. It doesn't sound like there's any examples right now, but I think it's a good question to ask on Zulip to keep the discussion going. So I will share my screen with the purported solution
Ooh.
by GTP5 Pro. So let me share my window. I will also copy it. No, I don't want that window. I want that window. I will also hit send on the Zulip message just now. Okay, can everyone see it? Oh, it's probably tiny, isn't it? A bit better.
Yeah, it's perfectly visible.
So hard for me to see.
Oh, that looks like did I make a mistake? That looks too simple. Wait, doesn't
Well, it's not correct. It doesn't.
it's
I
not
mean, we got
correct.
two errors. We got two errors. One is that we don't know what S is here.
Oh, it's trying to do a diagonal trick. What?
Yes. And yeah. So you can play with that. You can play with that because I copied it into the Zulip chat yourself. But since we're over time, I want to thank everyone for coming and contributing to a very interesting discussion. I'll see you on Zulip some more, and of course in 2 months. Until then, take care.
Thank you very much for organizing.